Okay, so as in the last video, we have completed solving the MCQs from the Ecat book. So from today, we are going to start the MCQs, solving the MCQs of the atomic structure from Kips book as well. Alright, so as you can see this topic, right? Today we are going to solve the atomic structure MCQs from the Kips book, right? Okay, so wait for a while. Let me highlight the topic. Okay, so atomic structure MCQs from the Kips book, right? So let us start with the first MCQ. What are they asking us? Initially, we'll be trying to complete 25 MCQs in today's video. From the next video, I'll try to solve the MCQs from 26th, right? So our today's main motive would be solving the MCQs till 25th, right? So let's see what are they asking us in the first MCQ, right? So the value of E by M for the electron is, we have calculated that is 1.7588 into 10 to the power 11, positive 11, right? So as you can see, 1.7588 into 10 to the power 11, okay, this is correct. 1.755 into 10 to the power 11, correct. 1.755 588 into 10 to minus 11, which is not correct, right? So 1.7588 into 10 to the power 11, which is again correct, but the unit is not correct, right? So first option, which is A, and option C are both correct, right? Because they both are same options. So we are going with, right, with it. Our correct option is 1.788 into 10 to the power 11, right? So our first option is correct as well. So here I would mark both these, right? I'm not marking both of these, however, okay, we know A option is correct as well, right? So second, how many times the mass of neutron is greater than the mass of electron? We know that the mass of proton is 1836 times greater than electron. However, they are asking us the neutron mass from the electron, right? So the mass of neutron is 1840 times greater than the mass of electron, right? If they would have asked us about the proton and the electron, so the mass of proton is 1836 times greater than electron, but they have asked us here about the neutron, right? So our third MCQ is the mass of proton is, we know that the mass of proton, in the mass of proton and the electron, there is a slightly, however not, because the mass of electron is very much lighter. However, there is a bit difference in the mass of proton and the neutron, right? There is a slight difference in the mass of proton as well as the mass of neutron. However, they are asking us here about the mass of proton, right? So initially the mass of electron is 9.11 into 10 to the power minus 31 kg. So this is for electron, all right, the first one. Second one, 1.602 into 10 to the power minus 19. This is basically the charge of an electron, right? They have asked us about the mass of proton. So 1.6726 into 10 to the power minus 27, which is the mass of proton, right? This is the correct one. 1.6750 into 10 to the power minus 27 kg, right? So we know that it is 1.6726 into 10 to the power minus 27 kg is the correct option, right? So the third MCQ B is the correct option. Let us go with the fourth one. What will be the effect on proton when passed through the electric field? When we made a proton pass through the electric field, right, where it will gonna deflect, right? So for example, right? If basically we are making proton to pass through, you know what, the electric field. Basically this, I have proton, right? Here I have positive, which is basically cathode. Here I have negative, which is anode, right? So here this is basically representing anode, and this is cathode, right? So this is anode, this is cathode. So positive charge, we know that it won't go to the anode, right? If it will go to the anode, there would be repulsion, right? So this positive charge, this positive charge, this positive charge must go or reflect towards the cathode, right? Must go or reflect towards the cathode, which means it will go and it will be reflect towards the cathode. It will be reflect towards the cathode. So deflection towards cathode, B is the correct option. B is the correct option, right? Because if you read the first option, deflection towards anode, it won't be deflected towards anode, since we know that anode has positive charge. Deflection perpendicular to the electric field, why? Of course, why there would be the perpendicular deflection towards in the electric field? So it doesn't make sense, right? So B is the correct option, which means deflection towards cathode, right? So our fifth MCQ, which one is not true about cathode rays? What? They have given us something wrong in it and we need to identify that. So if I read the first option, which is, of course, I can see it is the mass of electron, 9.11 into 10 to the power minus 31 kg, which is of course correct, right, about cathode ray. Cast shadow, if we put a pedal wheels in the discharge tube, they will gonna cast shadow, so this is correct as well. Heat up the platinum foil, of course, electron has the power, or cathode ray has the power to heat up, you know what, the platinum foil. D, cannot ionize. We have read the property of the cathode rays, in which I have explained in very detail that cathode rays can ionize, right? Here they are asking cannot ionize. So of course our D is the wrong option, because we know that electron can ionize. Cathode rays can ionize, right? Sixth MCQ. Positive rays are produced by burning of gas. Okay, let's see. Let's read the other options. Then we're gonna identify what is right. By cooling of gas. Okay. By the bombardment of cathode rays on gas molecules. We have initially discussed. When we were discussing about you know what, the discharge, or you know what, the production of the positive rays, or you know what, the negative rays. This is basically the discharge tube, right? This is the discharge tube. Here I have zinc sulfide plate. Right? What are they asking? Positive rays are produced. We know that when we made it connect through the potential, right? When we made it connect through the potential, here basically we have positive charge and here we have negative charge. So we know that electrons will be moving from positive to the negative, from higher potential to its lower potential. All right, so electrons are moving from here, right? And here we have discussed that here we have basically anode, right? Here we have cathode have negative charge, anode have positive charge, right? So when electron will gonna pass from here we know that the entire discharge tube is filled with the gas, right? Here basically I have hydrogen, right? Initially we have read that this electron, when will be hit on this gas molecule, they'll gonna break the bond of it, and then here would be only one proton left, and that would gonna, you know what, would gonna attract towards the zinc sulfide and will gonna produce a glow on it, right? So we know that by bombardment of cathode rays, which they are representing here electrons, right, on the gas molecule, is the correct option. The bombardment of cathode rays on gas molecule is the correct option, and this is how the positive rays are produced, right? So our seventh MCQ, a fast moving neutron can eject from nitrogen alpha rays, right? A fast moving neutron, can eject from nitrogen is alpha rays. Very common, right? Okay, so now we have, pressure in gas discharge tube was kept not 10 torr, not 1 torr, not 0.1 torr, however 0.01 torr, right? 0.01 torr, right? Positive rays give flash on. I have just told this now. The entire discharge tube is covered with zinc sulfide, since when positive or negative rays hit on those, they produce a glow, right? So there is zinc sulfide coating on the discharge tube. 10th, free neutron changes into proton with the emission of course neutrino and the electron, right? Neutron is the energy which will be emitted if you are changing your neutron to the proton, and electron would be emitted as well, because we know that neutron is basically a combination of electron, proton and neutrino. So if you are changing neutron into proton, so one proton would be left only and electron and neutrino would be ejected, right? Now 11th, charge of electron was measured by. Who measured the charge of electron, right? We know that Millikan measured the charge of an electron. Millikan measured the charge of an electron by the oil drop experiment. By Millikan's oil drop experiment, we have got the charge of an electron. Bombardment of alpha particle on beryllium atom emits neutron, and this process is called, this is basically not natural radioactivity, because natural radioactivity is, when action is happening by itself, right? This is artificial radioactivity, since we are making alpha particle bombard on the beryllium. Thus in the end the neutron is, the emitted out, right? So this is artificial radioactivity. If you read third option, not third, however, B option, Pauli exclusion is, of course this would not be here, this would be in the quantum numbers, right? Hund's rule, this would be in the quantum number as well, means electronic configuration, right? So our 13th MCQ, what are they asking us? Okay, so neutron is one of the fundamental particle of atom and carries a charge of one unit and a mass of 1. We know that it carries mass of 1 unit, but it doesn't carry any charge. No charge and no mass. No mass is correct, but no mass because it has 1 unit mass, right? So B is not correct. No charge and a mass of 1 unit. Yes, this is correct because it has no charge. However, it has 1 unit mass, right? And if I read about the D option, a charge 1 unit and no mass, of course this is wrong. It hasn't charge, it has mass, right? So our correct option is C. Let's read or solve the MCQs from the Rutherford's model of an atom and X-rays atomic number, right? So Rutherford planet-like structure was defective and unsatisfactory because moving electron accelerates towards the nucleus, which was he couldn't explain the stability of an atom because of, Maxwell electromagnetic theory. He says any accelerated charge particle will gonna emit energy, will gonna revolve and emit energy. If this electron will emit energy, this must be fall towards the nucleus, right? How was our the model here? Sorry. Okay, so here basically I have nucleus in mid. Here I have nucleus in mid, and electron is basically revolving around it. Electron is basically revolving around it, right? Electron is basically revolving around it. According to the Maxwell electromagnetic theory, any accelerated charge particle will gonna emit energy, right? If it will gonna emit energy, if this will gonna emit energy, this must be fall to the nucleus, right? So the spiral model should be formed. So this first option is correct, right? Because they have asked us about the unsatisfactory point. So if I read about B, behavior of electron remain unexplained, yes, correct. C, continuous spectrum, there was continuous spectrum of the hydrogen, right? However, hydrogen produced discontinuous spectrum, but according to the Rutherford, there was continuous spectrum. So all options are correct, which means D is the correct option. All are correct, right? All are correct. Rutherford bombarded dash particles in discovery of neutron. He used alpha particle in the discovery of nucleus, right? 16. When alpha particles are sent through a thin metal foil, most of them go straight through the foil because most of the part of an atom is empty. This is the reason make them pass through the metal foil, right? So most of the part of the atom is empty, right? Increase in atomic number is observed during beta emission, right? If I do talk about example here, of course, because I am explaining here the MCQs, right? So I should give you guys example. If I have copper here, Cu plus, or it is converting, not plus, right? This doesn't suit our chemistry, right? It is converting it to zinc, right? What it will gonna produce, right? Or you can not write here equals to sign, however plus, because we are emitting beta, which is fast moving electron, and we know that electron has minus one charge, and zinc has copper has 29 atomic number. Zinc has basically 60 atomic number, if I am not wrong, if I am correct with all the characteristics. So I guess zinc has 30. 66 is basically the atomic mass of it, right? So zinc has 30 atomic number. Now let's write their masses, right? Copper mass is basically what? It is 66, right? 66. Zinc mass is 66 as well, and electron has no mass, so 0, right? So if you see, they are asking when electrons increase in atomic number, so we know that from here to here atomic number is increasing, right? From 29 to 30, there is no difference in the atomic mass, plus electron is ejected, means beta emission, so this satisfies, right? So there must be beta emission since there is an increase in the atomic number. 18th, when electrons collide with heavy metals, then dash are produced, X-rays are produced, right? When fast moving electron collide with a heavy atomic number of the metal, it produces X-rays. 19, atom with higher atomic number produces X-rays of shorter wavelength, right? Shorter wavelength. This theory, right? Here I don't feel that I should give an explanation, right? Where explanation is needed, I am trying my best to provide you guys with the explanation. So 20th, all of the following were theorized by Bohr in his description of an atom except angular momentum is integral multiple of h by 2 pi. This is correct. Electrons revolve in discrete circular orbit, correct. Energy of each electron is directly proportional to the n square, correct. Electrons radiate energy continuously in a given orbit, which is wrong, right? They do not radiate energy in the continuous manner, however in the discontinuous, right? 21, the relationship between energy of photon of light and its frequency is given by Planck's quantum theory, which is basically E is equal to h by naught, E is equal to h mu, right, where mu is the frequency. So the velocity of the photon is of course the independent of its wavelength. It do not depend on the, you know what, the wavelength of it, right? So the correct option here is what? It is basically A. It is independent, right? Independent. Okay, so Planck's theory was says energy is emitted in discontinuous form, in continuous form, simultaneously in the form of heat. So here, of course, the correct option is discontinuous form. When we were discussing about Planck's quantum theory, I told you guys in very detail that energy emitted would be in the discontinuous form, right? Angular momentum of an electron, n square h by 2 pi no, n h square by 2 pi no, and h by 4 pi no, and h by 2 pi is the correct. Where we read angular momentum of an orbit would be integral multiple of h by 2 pi, where integral multiple represents n, which means nh by 2 pi, where n represents the shell number. 25th, the last MCQs for today. Planck's equation is E is equal to h by 2 pi. Planck's quantum theory, right? Where mu represents the frequency. So today we are done with, you know what, the 25 MCQs of Kips. In the next video we will try to solve the MCQs after 25 as well. So this was all for today.